The input voltage Vi to the two-level clipper shown in the below figure varies linearly from 0 to 150 volts. Assuming ideal diodes, plot the transfer characteristics. Okay, it's similar to the previous problem only. So how do we do this? See this. First of all, the input is 0. Then what happens to the diode D1? The cathode is going towards 0 volts and the anode of the diode D1 is going to 100 volts. D1 is on. Once D1 is on, it acts as short circuit so that the voltage here will be 100 volts. If it is 100, then anode of D2 is at 100 and its cathode is going towards 25 volts. So D2 will also conduct. Means when input is at 0 volts, both D1 and D2 are on. That's it. This is the first case we can take. Case 1, D1 and D2 are on. So that this is the equivalent circuit. We can see. From this equivalent circuit, what is the output? It is simply 100 volts. First case. Done. How long this is valid? It looks like this is valid as long as the input is less than 100 volts. Okay. The cathode voltage is less than anode voltage. It looks like. We are not sure that exactly whether it is exact 100 volts or not. Let me take that as a breakpoint one. So above circuit is valid if V input is less than breakpoint 1. Okay. Then input is greater than breakpoint 1 such that the diode D1 is off, maybe above 100. Then what happens? It is more than 100 volts so that D1 is becoming off. And what about the status of D2? Here the input is more than 100 means the voltage here is also more than 100. So D2 and anode of D2 is at a voltage more than 100 and cathode is going towards 25 volts. D2 remains in on state. That's it. So case 2, D1 is off and D2 is on. So equivalent circuit, you are applying a voltage more than 100 volts. Even though D1 is initially for D2 to conduct, D1 is responsible. V1, the voltage V1 is responsible. Then if the input is greater than breakpoint, even though D1 is off and V1 is nowhere connected to D2, anode of D2, D2 will be on due to V input, but not due to V1. That's it. So D2 acts as short circuit. Input. As far as the circuit is concerned, we have already gone through this in the previous problems. So V output is equal to 2 by 3 V input plus 25 by 3. And how long this is valid? Above breakpoint. Right? So looks like 100. Above 100, maybe 110, 120, 130, 140, 150, up to 150. Maximum value of input is 150. Even for 150, this is the only circuit possible. Circuit 2, case 2 is possible. Okay. So any other case possible? Is possible? No. So above circuit is valid if V input is greater than breakpoint 1. That's it. No other circuit is possible. What is the breakpoint? At breakpoint, V output is equal to 100. It is also equal to 2 by 3 V input plus 25 by 3. Implies V input is equal to 137.5 volt, which is our breakpoint. That's it. What they are asking, okay, these are the two possible cases and the corresponding output equations. Next, the breakpoint value. Everything we have got. Now we can comfortably draw the transfer characteristics. What do we get? One graph is coming like V output is equal to 100 volts, and another is like V output is equal to 2 by 3 V output, sorry, 2 by 3 V input plus 25 by 3. It is similar to the equation Y is equal to mx plus c. Intercept on y-axis is positive. It is like 8.33 something. Next, what about the breakpoint? We can see the breakpoint here. Point of intersection. Breakpoint 1. We have only one breakpoint. It is 137.5 volt. If input is less than breakpoint 1, output is equal to 100 volts. Input is greater than breakpoint, output is equal to 2 by 3 V input plus 25 by 3. That's it. This is how we can draw the transfer characteristics. It's a very simple question. Right. Next one. For the circuit shown below, assuming that the GNR diode is ideal with a breakdown of 6 volts, the waveform observed across GNR diode is. It's a very simple question. Okay, let us start with input with negative peak to positive peak. If the input is minus 12 volts, then what happens to the GNR diode? Minus 12 means minus plus it is 12. Then anode of diode is going to positive terminal and the cathode is going to negative terminal. Definitely the diode is forward biased. Once it is forward biased, ideal case, we can take it as short circuit. So what is output? Simply 0. Okay. So case 1. If we take diode is forward biased, then the equivalent circuit is something like this. What is the output here? Simply 0. Okay. How long this is valid? As long as input is negative during the complete negative cycle, I can take. If it is positive, then diode will be reverse biased. Okay. So positive input is negative. I can say instead of that is less than 0 volts. Ideally speaking, less than 0 volts. Or for safe side, what I can write? Input is less than breakpoint 1. Okay. Above circuit is valid if V input is less than breakpoint. Okay. Next, input is greater than breakpoint 1 or positive, and of course less than the breakdown voltage of the generator. That's what you can see. When the input is positive, that time what happens? What is possible? Diode is reverse biased. And how long the diode remains in reverse bias? As long as the input is less than the breakdown voltage of the GNR diode. If the input is more than breakdown voltage, then the GNR diode undergoes GNR breakdown and it maintains a constant voltage of 6 volts across it. And here what case I am looking at? Input is positive and less than the breakdown voltage of the GNR diode. That's it. So case 2. Diode is reverse biased. Means the diode simply acts as open circuit. What is output? Output is equal to input. And how long this is possible? This is possible. Above circuit is valid if breakpoint 1 less than V input less than breakpoint 2. Input is positive and less than the breakdown voltage of the generator. Then we can take it. So next, case 3. Input is more than 6 volts, means the breakdown voltage of the Zener diode. Then what happens? The Zener diode undergoes Zener breakdown and starts conducting in the reverse direction so that it maintains a constant voltage of 6 volts across it. So the diode undergoes Zener breakdown, or I can write Zener diode undergoes breakdown or Zener breakdown. So what do we get? It maintains a constant voltage of 6 volts from cathode to anode. So what is V output here? 6 volts. And how long this is valid? If the input is greater than 6 volts, it looks like under ideal conditions. Let me write it as breakpoint. Above circuit is valid if V input is greater than breakpoint 2. That's it. Is there any other circuit possible? No. Diode forward biased, first case. Next, reverse biased with open circuit. Next, undergoing Zener breakdown and maintaining a constant voltage of 6 volts across the diode. That's it. So let us find the breakpoints. At breakpoint 1, V output is equal to 0. It is also equal to input. Implies breakpoint 1 is equal to 0 volts. At breakpoint 2, V output is equal to V input. It is also equal to 6 volts Vz. Implies breakpoint 2 is equal to 6 volts. Now we can take the transfer characteristics. First case, if the input is one case is V output is equal to 0 or Y is equal to 0, means it is x-axis. Second case, output is equal to input. And third case is V output is equal to 6 volts. Now we can see the breakpoints. This is one breakpoint whose value is 0, and this is another breakpoint whose value is 6 volts. So case 1, first case is possible for input less than breakpoint 1. Output is 0. Next, if input is in between 0 and 6 volts, diode is acting like open circuit and output is equal to input. If input is greater than 6 volts, output is 6 volts. Right. This is how we can see the transfer characteristics. But what they are asking us the waveform observed across the diode. Okay. First case, input is, okay, let me take with respect to the 6 volts. Input is less than 6 volts, output is equal to input. Input is greater than 6 volts, output maximum is 6 volts. Next, in between 0 volts and 6 volts, output follows input. When input negative, simply output is 0. So ultimately we can see the output waveform this way. And if you observe this circuit, right, here I'm using only one Zener diode, but it is equivalent to a circuit of 2 diode Clipper circuit. Diodes D1, D2. You check the transfer characteristics and waveform of this circuit, that is same as that of the problem we did. Okay, that's it.